So, welcome back. We will continue the topic of Burrows Wheeler indexes. We closed the last lecture by discussing the Burrows Wheeler transform and how we permute the characters of the text to obtain the Burrows Wheeler transform. This is an extremely simple method. So, all we did is took the rotations, all the cyclic rotations, we sorted them lexicographically, and we just looked at the last column of this matrix to obtain the Burrows Wheeler transform. Then in the last lecture we also looked at why this transform is useful for compression, because for large text it brings the equal characters together, and that property is useful for compressing text using run length encoding. The focus of this lecture is going to be, given this Burrows Wheeler transform, how do we go back to the original text? Because if this can be used as a compression algorithm, there has to be a way of recovering the original text back from the Burrows Wheeler transform. Okay, so given the Burrows Wheeler transform of text T, how do we go back and recover our original text T? So, let us answer this question in the next few slides. As a starting step, let me define columns F and L. So, column F is the first column of this matrix and column L is the last column of this matrix, right. Observe that as a first step, column F has a very simple structure, that is, it starts with dollar symbol, then you see consecutive A characters, and then you see consecutive B characters, which makes sense because if you think of sorting all the suffixes or even sorting all the cyclic rotations, then all you will see is distinct. If you look at just the first character, then all you will see is consecutive runs of distinct characters in the alphabet. So, the first character will be dollar, then the next two characters will be A's, and the next two characters will be B's, right. Similarly, if it is a DNA sequence, then you will see a dollar symbol, then A characters, then C characters, then G characters, and then T characters. So, the column F follows a very simple structure that is easy to understand. Let us look at column L also. So, column L is equivalent to Burrows Wheeler transform, but let us look at this further. So, the next step of my strategy is following. What I am going to do is I am going to label the characters of the text T by their rank in column F. So, for example, this is the first occurrence of dollar symbol in this column. So, I am going to mark it as rank 1 because this is the first occurrence of dollar symbol. For this character A, I am going to give it a rank 1 because this is the first occurrence of character A. Similarly, this is the second occurrence of character A, this is third occurrence of character A, this is fourth occurrence of character A. Then this is first occurrence of character B, this is second occurrence of character B. So, using this I am giving a rank to each of these characters based on their ordering in column F, and I can label these, or I can sort of assign these ranks in text T as well. So, for example, dollar gets rank 1 because there is only one occurrence of dollar. Then based on this I know that the character A which precedes dollar symbol should get rank 1. So, therefore, the character that precedes dollar symbol gets rank 1. Then the character corresponding to suffix AABA dollar gets rank 2. So, here this symbol A gets rank 2. Similarly, the character A corresponding to suffix ABA dollar gets rank 3 and so on. So, we can put ranks to all the characters based on their column in F. So, based on these values we can put the labels on text T as well. So, in this case this will be 1 and this will be 2. Okay. So, now that we have assigned ranks or assigned labels to each character in the text T, we can also assign or we can also sort of give the same labeling on column L as well. So, based on this label I can give a label to column L as well. So, for example, corresponding to each character has an occurrence in column L. So, that occurrence, based on that occurrence I get a label as well. So, for example, again the character A preceding dollar symbol, that is character A preceding dollar symbol, the rank matches here, right. So, the corresponding these labels are now consistent and these labels are defined based on their ranking in column F. So, basically we have applied these ranks to labels in text T and then we have also applied these labels to column L. Okay. So, now wait for a few seconds, observe these two columns F and L. Do you see anything interesting? Do you see any special property that we can use based on these labels? Well, observe that the relative ordering of A's or relative ordering of B's in column F and column L is same. That is, in column F, A1 occurs before A2, before A3, before A4. That is because of the ranking that we did. But if you see column L as well, A1 occurs before A2, A2 occurs before A3 and A3 occurs before A4. So, that is the property that we have to capture here, that the relative ordering of dollar A's and B's is preserved in column L. Why is that happening? Is that a coincidence or will this generally hold? Well, this will generally hold, because if you see, if you compare these two characters A, so if you look at these two symbols, A3 occurs before A4 because of the ordering of these suffixes, right. So, BA dollar is lexicographically smaller than the longer suffix BAA, BA dollar 1. So, that is why A3 occurs before A4. But that is also the same reason why A3 occurs before A4 here. Because remember that the Burrows Wheeler transform, this character precedes this suffix. Similarly, A4 character precedes this suffix here. So, naturally if suffix Ti is less than Tj, then this will hold if and only if suffix Ati is less than suffix Atj, right, where A is a character from alphabet sigma. So, due to this property we know for sure that the relative ordering of dollar symbol A's and B's will be preserved in column L as well, right. So, now we have to capitalize this property in reversing from Burrows Wheeler transform to the original text. So, okay. So, let us answer this question now based on this property now that we have understood. Suppose your text T has 300 A symbols, 400 C symbols, 250 G's and let us say 700 occurrences of T symbols, and we will assume the standard order that dollar symbol is less than A, then A is less than C, C is less than G and G is less than T. Now, without having access to the entire matrix, so for this text let us say we build the entire, we take the cyclic rotations, we sort them, right. what do you think, which row number begins with C100 symbol? So, try to think of all the lexicographical rotations, sorting them. What do you think, which row of this matrix will begin with symbol C100? Well, to calculate that, remember that this we are talking about the F column here, that is column, the first column. So, we know that the first column will start with dollar symbol, then you will have all the A occurrences. So, A1, A2 until A300, and then your C occurrences will start based on the lexicographical order. So, then you will have C1, C2 followed by C100 and so on. So, we immediately can tell which row number will start from C100, that is you have to consider 1, then 300 and then 99. So, considering these many rows occurring before it, we can say that the C100 must correspond to 400 first row in my matrix, because there are 400 rows before it that will occur because of the ranking of A's and C's, right. So, this is again showing you that because of the lexicographical ordering, C100 will correspond to 400 first row in the Burrows Wheeler transform matrix. And this property comes from the fact that column F has a very simple structure. It starts with dollar followed by block of A's followed by block of C's. Okay. So, now given any symbol like C100 or C50 or T100, I can immediately tell which row number corresponds to that symbol in my column F. So, this logic is very simple and we can use this logic in our decompression algorithm, that is going back to the text T from the Burrows Wheeler transform. So, here is what we will do. We will try to reconstruct text T in the reverse order. So, we will start with the dollar symbol. We know that the last character of text T is always going to be dollar symbol, and we also know that the first row of my matrix is $1, right. So, remember that we actually do not have access to this matrix, we only know the Burrows Wheeler transform. So, while reconstructing the text, we cannot assume that we have access to the original matrix, that is just for our illustration purposes. All we have access to is the Burrows Wheeler transform, and we have to understand how we are going back to the text T from Burrows Wheeler transform. And for that, I can start from first entry of the column F, that is dollar symbol, and I know the character preceding dollar symbol. So, from column L I can know immediately what character precedes dollar symbol, because these are cyclic rotations. I can tell that A character precedes dollar, therefore, my next character in text T will be A. Okay. So, what about the next character? So, from dollar we went to A, but what is next to A? Well, for that what we can do is we can ask which row in F corresponds to A1, and that we will do based on the logic that we just discussed. For A1 we can tell that okay, A1 must correspond to second row of column F, because we can only have the dollar symbol before A, then we immediately should have A1 symbol in the column F. So, therefore, second row of my matrix must correspond to A1 symbol, and from here I can tell that before A1 my next symbol is B1. So, then I can reconstruct my next symbol in the text T, which is B. So, now you can see the procedure. Basically we are going this one at a time. So, this we are at one stage we are at column F, then we are moving to column L, and then we are moving to column F again, right. So, this jumping from L and F is what we need to do to reconstruct the original text. So, from B1 we have to again think of what row would correspond to character B1. You can imagine that because there are 4 occurrences of A and $1 symbol. So, therefore, 6th row in my column F will correspond to B1 symbol. I have to jump to that row and fetch the previous character, which is A. So, again my next character will be A in my text T, and continue to do that procedure until we reconstruct the complete text. So, this mapping from column L to column F is often called as LF mapping in the algorithms literature, and using this LF mapping we can reconstruct the entire text T starting from the dollar symbol and making our way one character at a time, moving back. So, this covers the algorithm, but we have one minor detail to be filled, is that we are assuming that we have access to these columns F and L. How do we get column F and L? Because our original input is only Burrows Wheeler transform text, right. So, for example, for you may have this access to this Burrows Wheeler transform, and only from this transform you have to recover the text. So, how do you get these columns F and L from this Burrows Wheeler transform? Well, first column F is very easy to get, because for column F all we need to do is to count how many dollar symbols are there, how many A symbols are there, and how many B symbols are there. So, for example, if there are $1 symbol and then 4 A symbols, and then we have 2 B symbols. So, column F is trivial to construct. What about column L? Well, column L, at least the characters are equivalent to Burrows Wheeler transform. So, if you think of column L, we just have to list all the characters in the Burrows Wheeler transform. So, that is, I just listed the Burrows Wheeler transform, which is basically the last column. But what about the ranks? So, what about these red symbols? Well, for that we know that the rank of these characters is preserved, that we have already seen. So, therefore, the first A character can be given a rank 1, the next B character, this can also given a rank 1. Until here we have already one B character, so this has to be given rank 2. Until this point we have seen one A character, so therefore this will be given rank 2. Dollar will always be given rank 1. Until here we have seen 2 occurrences of A, so this will be given rank 3 and 4. So, again getting column L is also trivial in some sense. All I need to see is list the Burrows Wheeler transform and then mark the individual ranks of that symbol based on how many characters of the same type I have seen until then. So, this summarizes the algorithm that we use to get back text T from the Burrows Wheeler transform. From the Burrows Wheeler transform, first you have to know the columns F and L, and once you know the columns F and L, we can use this LF mapping, that is going from dollar symbol to A and then A to next B1 and so on. We can use this LF mapping to reconstruct our original text T. So, this covers how, given Burrows Wheeler transform, how do we go back to the original text. The final question that we have to answer now is, how is this compression technique useful for pattern matching? Because all you have access to is Burrows Wheeler transform, how can this Burrows Wheeler transform support the functionalities of suffix trees or suffix arrays? That will be the topic of next lecture. Thank you.